Okay, hello everybody. Good morning, all of you. Good evening. I hope that you guys are doing very well, and also your preparation is going very well, guys. I hope so, and I hope that I am audible to you. Visibility is very clear to you. And as you know that it's lecture number 21, we are studying the classical thermodynamics, which is the first part of your thermodynamics, right? Second part is your solution thermodynamics. So it's lecture number 21. I hope till the 20th lecture everything is clear to you. There is no doubt. And as I already told you that do not hesitate to ask the doubt. Just put your doubt on the Telegram group. That's it. This is the only task you have to do. Right? And yeah, welcome again. Welcome again. So today let's take the quick revision as this is our, you can say, the routine practice. So just take some you can say minutes for the to revise the previous lecture, right? And as you know that, as I told you that this slide is very important. So let's start this. So we were studying the Maxwell relations, guys, right? So what I told you that like pressure, volume, and temperature, PVT, these are the relations actually. These are the relations actually, which is you can say that these are the properties actually which are measurable, and some properties like internal, Gibbs, enthalpy, entropy, these are the derived properties, right? So if we want to connect the measurable property to the derived property, then Maxwell relations basically will help us. Okay, so there are some specific relations which gives us the value of the relations, and so we do have the four relations of the Maxwell relations, right? So my first part is these are the four relations. First part is my remember these four relations. So for this to remember these relation, there is only one trick that is very useful, that is tapasvi. So in the final, please pay attention here, and listen me carefully what I'm saying. I'll say here two or three things I'm telling you, okay, and you have to put in your mind every time, because this is important actually. Most of the time the question is asked from here only. So we have three properties, PVT, and one property, that is entropy. So in the final Maxwell relations, these are the four properties which we are using, right? So we made a trick that is called tapasvi, right? So Ta stands for T, Pa stands for peace, Se stands for S, and V stands for V. That's it. So see, you have to make this tapasvi whether you are going clockwise or whether you are going anti-clockwise. It's your choice. There is no issue, right? And also you can start from this end, 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 right? So that word you can start from anywhere. There is no problem at all. This is my this is the first point, right? Second point is, see, if you are going let's suppose horizontal, to make this word tapasvi, if you are going horizontal, then in the relation you have to put negative sign, and if you are going vertical to make this word, then you have to put positive sign. That's it. Okay, like if let's suppose I make this word tapasvi by tapa like this, in going horizontal direction. So this is tapasvi, right? And I'm going to horizontal direction. So if I'm going to horizontal direction, then I have to put negative sign. So ta, pa, sa, and v, right? This is the way to make this word. See, do not, you cannot go like this, ta, and you can go diagonally, pa, sa, v. No, this is not the way, right? So you do not have to go jig and jag. You have to go only the specific path, the pa, sa, v, right? Now, okay, so this is the temperature change with respect to volume. So entropy must be constant. Yes or no? See, Here you can see only the two where you can see the change dV and ds. So here if you change in the volume, then entropy must be constant. And here in this ratio, S is the variable, or you can say change in the S, then volume must be constant. That's it. So these two variables are exchanged now. Here it is S and here it is V. If you are making the tapasvi word like this, vertical direction, tapasvi, like this, okay? So you are going vertical, so you have to put positive sign. Very simple. Here it is pressure, here it is entropy. So in this ratio, pressure is variable, then entropy must be constant, and here it is my entropy, then pressure must be constant. That's it. Okay, so you can go like this also. I told you initially, then you can go, you can start from here, 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 here. There is no problem. Let's suppose I'm starting from this. So it is tapasvi. Again, I'm going horizontal, so I have to put negative sign. Okay, I'm starting from here. Tapasvi. Then it's also, it is a vertical direction, then you have to basically put the positive sign. These are the four relations, right? So it is very simple, guys. It is very simple that see, just put, if you are exactly want exactly these four relations, then do one thing, just start the pursuit from the left hand side, right? Left hand side, is it clear to you? Means two times from this, from up, two times t word must be on the numerator. In the first relation going horizontal, in the second relation going vertically down, right? Second, the in the two relation, the del t must be on the denominator, and going in the first, to calculate the first relation, going horizontal, and for the fourth relation going vertical. That's it. You will get exactly the same relations which we already calculated, right? So there is no need to further manipulation of the equation, right? So first thing is, what is the first thing important? That these four relations between T, P, S and V. Second thing is important is that which relations stands for which equation, right? This is basically, I already told you. So again I'm telling you that, see, this is my del T over del V, keeping entropy constant, is equal to minus del P over del S, keeping volume constant. This is my equation number one. So in the question, and I attached some PYQs related to this. So you should know that this relation is related to this equation, or this equation, or this equation, or this equation, right? So you should know this. So you'll say, sir, how we basically know this? How will we got to know this, that this relation is related to what? So the funda is very simple, guys. The funda is very simple. See, if you can see here that this is my change in internal energy, the equation is TdS minus PdV, right? So I think this equation is the very simple to calculate, right? Yes or no? This equation is very simple to calculate. I can calculate this. Now du change depend upon the entropy change and the volume change. It means that this internal energy is the function of entropy and the volume. This is the very important point, right? And here also you can see that in this relation, what are the variables? Entropy and the volume. If you will see in the equation C, this equation stands for entropy and volume, but it is entropy pressure, it is pressure temperature, it is volume temperature, right? So variables are different in all the four cases. Yes or no? So just see the variables. If I'll have this equation, I'll see that what are the variables. So these are the variables S and V. Okay. So which parameters depend upon S and V? So we will say that internal energies depend upon the S and V. How do I know that the internal energies depend upon S and V? It is coming from the base equation. This is the equation. Yes or no? I hope that it is clear to you. Okay. That is clear to you. Right? Right? Similarly, the H is equal to U plus PV. I think I should take some slide to Need to understand this. Okay, see, so my first equation was du is equal to TdS minus PD. This is my first equation from which Maxwell's first relation will come, right? From this equation, I can say that my internal energy is the function of entropy and the volume. Okay, clear, right? And my first relation is that is my first relation coming from the del T per and P, keeping entropy, keeping volume constant, and if you are going horizontal, then I'll put negative sign. So this equation is for this equation for internal energy, right? Is it clear to you? So this equation stands for, what is the base equation for this equation? Internal energy equation. So this is my second point, which is important. Now, third important point is, see, so my internal energy is the function of, your entropy and the volume. Okay, can I write du as, see, I hope that you know this, you are aware about it, because this is the very basic thing, that if this is my dependent variable and it is depend upon two variables, one is S and one is V, and I want to write its perfect differential, I want to write its du, then we can write the du in terms of the partial differentiation, right? So we basically use the partial differentiation in terms, you can say that we use the partial differentiation where the one variable is depend upon the two variables actually. Okay, only a dependent variables, if only depend upon only the one variable, then we will use the perfect differential or complete differential. Here we will use the partial differentiation. So how do you use this? See, first we will see the change of internal energy with respect to the entropy, keeping volume constant, into ds, plus after that we will see the change of internal energy with respect to volume, keeping entropy constant. This is the du basically we can write. I hope that this equation is clear to you. Please say that this is if this equation is clear to you or not. I hope that there is no problem in this equation. I hope that there is no problem in this equation. Right? So this is the way which we can which we write du. So this is my equation number 1, and let's suppose this is my equation number A. If I'll compare this, then one new term I can write. See, this is my ds, this is my ds. By comparing, I can say by comparing equation 1 and equation A, then I can write that del u over del s at constant volume is equal to T, and del u over del V keeping entropy constant is equal to minus P. Right? This is, we can write by the comparison. So whatever you see in this slide, all the things, only, or you can say even single line is important for us. Even single line is important for us. Everything is very, very important, and directly questions is asked based upon these facts. Right? So this is my first Maxwell equation. I'll talk about the second one, right? Second one is coming from the H, and H equation is dH is equal to TdS plus VdP. TdS plus VdP, right? So here, again, what is my second equation? So first equation is coming from the horizontal and second will come from the vertical. So the pa sa keeping entropy, keeping pressure, you are going vertical, then it is a positive. Now again the same calculation will be written here. See, H is the function of entropy and pressure. See, entropy and pressure, right? And we can write the dH in terms of the partial differentiation, that is dH is equal to del H over del S keeping pressure constant into ds plus del H over del P keeping entropy constant. This del is the sign of partial differentiation. This is the sign of partial differentiation, right? So you guys are at least I can say that the least class sitting in this basically preparation is second year, and up to the second year we are aware about the engineering mathematics and we already studied all these parts, right? But I'm not going in very deep because we are studying the thermodynamics, we are not studying the mathematics, right? So I'm using only the basic things and I hope that you are aware about it. If still you are not aware about it, then when the mathematics will you can say start, then you can see all these things. Okay, so dH is equal to del H over del S keeping pressure constant. If I'll, this is my equation number 2 and this is my equation number B. If I'll compare it, then after comparison I can write del H over del S keeping pressure constant is equal to T del H over del P keeping entropy constant as okay, right? Third is A dA is equal to minus PdV minus SdT. Minus PdV minus SdT. Okay. So what is this? A is the function of volume and temperature. I can write dA as del A over del V keeping temperature constant plus del A over del T keeping volume constant. This is my equation number 3, equation number C, right? By comparison, I can write that del A over del V keeping temperature constant as minus P and del A over del T keeping volume constant as minus S, right? And my third Maxwell relation, which is for the this A, it is my del P over del T keeping volume constant is equal to del S over del V keeping temperature, right? So this is my Maxwell relation for this. Okay, done. Fourth will be G, and G equation is VdP minus SdT. VdP minus SdT. So it means that G is the function of P and T. I can write dG is equal to del G over del P keeping temperature constant plus del G over del T keeping pressure constant. After comparison, I can write this. This is my equation number 4 and this is the equation number D. After comparison, I can write del G over del P keeping temperature constant is equal to V, del G over del T keeping pressure constant is equal to minus S, right? And what is the Maxwell relation for this? It is my del V over del T keeping pressure constant is equal to minus del S over del P keeping temperature. PNT, yeah, PNT, correct. Okay, so this is my Maxwell relations, right? I hope that it's clear to you. So in the Maxwell relations, and multiple times question is asked on these, you can say the 3 points, multiple times. Okay, like this is the question. IIT Kanpur, those are a 2001 question. The Maxwell relation derived from the differential expression for the Helmholtz free energy dA, right? This is about the dA. So if you know that A is the function of what, then you can first you can say that first you can first thing in your mind is that yeah, there should be two variables, this and this. It is clear to you? Like here, A is my function of V and T. A is my function of V and T, right? If you do not remember this, then also there is no issue. See, you know that it is the function of V and T. So just go to the options, V and T. So this is the option which stands only for V and T. This option, V and T, right? All the options are S and V, T and P, P and S. All the options are, you can say, from different variables. Now, one change I'll write here. Let's suppose instead of this option, C option maybe, let's suppose it is like del S over del V keeping T constant is equal to minus del P over del T keeping volume constant. I'll make it, you can say, more difficult for you, right? So see, in the original question, there is no need to remember anything. You can see here only the variables are, D option have only the T and V variable. Just click on this option and your equation is right. But let's suppose if in the both, if you'll have the, let's suppose the both options have the your T and V variables, then what to do? Then the trick will basically useful for us. So in this ta pa, so basically we are going vertical. So it is making like this ta, pa, sa and v, and we are going basically vertical. So if we are going vertical, then positive sign must be there, and here it is negative sign. So for sure it is wrong, right? So this is how that trick will basically will help you, right? It is clear to you? Also, if you want, you can write every equation that this equation stands for what. See, this is the pa sa v, the pa sa v. All this is the correct Maxwell, but it is the function of S and V. So I hope that you know that what is the S and V stands for. So again, next question is the pa sa v. It is also going horizontal, negative sign will be there. This Maxwell equation is right. Ta pa sa v. This equation is basically wrong because we are going the downward direction, you can say vertical direction, and it is negative. So your homework is just you have to write in your notebook that this equation stands for what, and this equation stands for what. Okay, done. Okay. 2014 IIT Kharagpur question. Which one of the following is correct for an ideal gas in a closed system? In a closed system. Read the question. Please read the question and tell me that which one is correct for it. Yeah, so I hope that uh, सबको सबने अपने माइंड में मेकअप कर लिया होगा कि कैसे इस क्वेश्चन को हम कैलकुलेट कर सकते हैं. हाउ डू वी कैन सॉल्व दिस क्वेश्चन. आई होप दैट यू गाइस आर make your mind right. So if you will see here that this is the ideal gas equation, all these four options are the format of ideal gas equation, and which we have to choose the correct one. So correct ideal equation is PV is equal to nRT. Okay, it is clear to you. This is the correct ideal equation. Okay, so let's, like in the first option, just pay attention here. It is my some term V is equal to NR this. It means it should be P and it should be T. Okay, if it is P and if it is T, then my first equation is correct. And if it is different from this, then it is wrong. Right? Again, so very simple. I know my U equation is, what is my U equation? TdS minus PdV. So it is so obvious that U is the function of entropy and the volume. Right? It is clear to you. So I will not repeat it again and again. We already done this part. This is my that part, right? So del U over del S keeping volume constant is T, and del U over del V keeping del U over del V keeping entropy constant is minus P. In the given question, del U over del V keeping S constant is basically my minus P. It's clear to you? That is my minus P. So this is basically my minus P. So my equation is according to the option A. According to the question A, minus P and it is V is equal to NR. Let's check the del U over del S is what? Del U over del S keeping V constant is T. It is T. So is this my ideal gas equation? No, it is not ideal gas equation, because it is PV is equal to nRT, not PV is equal to minus nRT. Right? Again, we have to check the H. Okay, do one thing. Just check the H wala function, right? So, okay. So it means that this part should be V and this part should be T. Yeah. Yes or no? Okay, just check from the previous slide because we have already calculated del H over del P. So del H over del P keeping entropy constant. Del H over del P keeping entropy constant is my V, right? But if you can see that, it is my minus del H over del P. So this stands for the V. That is my minus PV, my option A. This is my option A. Option B is, this stands for V, but it is my minus PV is equal to NR, and del H over del S, del H over del S keeping pressure constant. It is my T. It is again my minus PV is equal to NRT. This is also wrong. If you will check D, so del H over del P keeping entropy constant is my V. So it is my PV is equal to NR, and del U over del S keeping V constant is what? It is my del U over del S keeping V constant is T. Yes or no? Del U over del S keeping V constant is T. So this is actually the right equation. So D is my right equation. D is my right option actually. Okay. So what I'm saying that you should have the knowledge of everything, right? That's why I told you that every point is having, you can say every line has capable to crack any question, right? That what is this base equation, what is the function, what is the these stands for, what is the max relations for it. Okay, so this was actually my motto to make you understand that how these things are important for you. Okay, done. Okay, okay, now let's do some part, and after that we will move to the solve some questions. As you can see in our slides, there are some questions which we solved, right? Okay. One last part is there, that is the TDS equations. TDS equations. TDS equations. Okay. So we can, as you know, that we have the three properties P, V, and T. These are the measurable property, and entropy is my derived property. Entropy is my derived property, right? So derived means that this property is basically derived with the help of P, V, and T, with the help of measurable property, right? It is clear to you. So my first equation, let's suppose my entropy is the function of temperature and volume. Let's suppose my entropy is the function of temperature and volume. After that, we will make the function of P and T. After that, we will make the function of P and V, right? We will calculate all the TDS equations. So I hope that our agenda is clear to you. PBT is measurable, S is derivable, derived property. That derived property is calculated with the help of PV and T. It means it is depend upon PV and T, right? Means it is depend upon PV or VT or PT, whatever it is. Let's suppose I'll take first example. Let's suppose as entropy is my function of T and V. It is depend upon T and V. How? If we have the you can say the TV function, and how we can calculate the TDS equation. That is my funda. Okay, so very simple. Because entropy is depend upon two variables, so we have to write the partial differentiation actually, right? So how we calculate the partial ds is equal to del S over del T keeping volume constant into dt plus del S over del V keeping temperature constant into dV. This is my first equation. This is my first equation, right? It is clear to you. Because I have to calculate TDS equation, so do one thing, just multiply with the T in the on the both equation in the both side, right? So this T, T, and I just multiply the T with the whole equation, right? Done. It is clear to you. It is clear to you. It is clear to you or not, guys? I hope that it's clear to you. I hope that it's clear to you, right? Okay. See, uh, del Q is equal to TDS. Okay, right? So this, if I'll write this equation as that, see, we are basically doing this at the constant volume. Okay, we are doing this at the constant volume. Okay, del Q is equal to TDS, and if I'll write in terms of the differential equation, sorry, partial differentiation. So let's suppose I'm writing this. Okay, so del S is equal to del TD, it is my del Q over T. If we are doing this at constant volume, so at constant volume, there is no work done. There is no work done means every, you can say that every your amount of, you can say the heat is going into the internal energy, right? So this is my T del S is equal to del Q is basically del change in internal energy. And change in internal energy is nothing but it is CV and it is my dt, right? And in terms of partial, then I can write CV del T, right? So if TDS is equal to CV del T, so can I write this del D del S over del T, keeping volume constant is nothing but it is my CV. Okay, so this is the manipulation basically I have to, right? So guys, so this is my TDS is equal to this T del S over del T, keeping volume constant is nothing but it is my CV dt, right? Plus this is my T del S over del V, sorry, del S over del V, keeping temperature constant into dV is what? It is basically nothing but it is my del S over del T del V, keeping temperature constant is my del P over del T, keeping volume constant. Okay, right? So this is my, you can say the first, you can say your, can say your first TDS equation, CV dt plus T del P over del T, keeping volume constant. Okay, right? Second, let's suppose my entropy is the function of temperature and pressure. If it is the function of temperature and pressure, then I can write ds as ls over del T, keeping pressure constant into dt, plus ls over del P, keeping temperature constant in, right? Because we want the TDS equation, that then just multiply with the T. So this is my T, ds is equal to T del S over del T, keeping pressure constant into dt, plus T del S over del P, keeping temperature constant into. Okay, done. So likewise, del S over del T, keeping volume constant is Cv. So likewise, del S over del T, keeping pressure constant is Cp actually, right? So T del S over del T, keeping pressure constant is my Cp. This is Cp dt. Cp dt, right? And this del S over del P, keeping temperature constant is my minus del V over del T pressure constant. Okay, and it is my D. That is my D, right? So this is my Cp dt. So this equation I can write as TdS is equal to Cp dt minus T del V over del T, keeping pressure constant. This is my second equation. This is my second equation. Okay. I hope till this part that it's clear to you. I hope till this part it's clear to you. Right? I hope that it is clear to you. If you have any problem, you can ask. If you have any problem, you can ask. So this is my second TDS equation. Third equation is what? Third equation is PV. If let's suppose P and V is the, you can see the function. Okay. P and V is the, let's suppose is my function. Then you can use this equations. You can calculate this equation, right? Okay. Okay, so let's for today's itself, it's done from my side, guys. And actually, I have to go somewhere. There's a doctor appointment for my son, so that's why for today itself we have only, you can say, the 1 hour, right? So that's it from my side. And if you have any doubt, you can drop on the group, guys. Okay, thank you so much. Bye bye and take care. Let's meet in the next class. Just revise all these things, right? And in the next class also we'll sum the questions, and after that we will move to the pure substance chapter. Okay, thank you so much. Bye bye and take care.